at the social and economic feasibility of interventions to reduce greenhouse gas emissions intensities from livestock production in Kenya and in Ethiopia. And at that time, we really took a broad look across the range of production systems that we have in Kenya and in Ethiopia. And we focused on three major categories. So the first, and where the bulk of reductions in emissions intensities can come from, is improvements in feed quality to increase productivity. And again, this is really a win-win because if you improve the productivity, farmers improve their incomes and their milk yields. So we looked at four specific interventions: supplemental fodder from improved forage species, which is most applicable to mixed crop livestock systems, although it is sometimes used in pastoral and agro-pastoral systems as well. We looked at supplemental feeding with concentrates. This is really only applies to intensive dairy, but it's using commercially produced concentrates. Often these can be byproducts from beer processing, etc. We looked at the use of silage from maize, and then of greatest interest to this presentation is we examine the technical potential and the feasibility of managed grazing, which is suitable for extensive pastoral as well as agro-pastoral. Next slide, please. We also do quite a bit of work on manure management. Manure management is often a nice entry point in for farmers because there are significant co-benefits in terms of improvements in soil fertility and crop yields if they manage their manure better. The two options we looked at, one are biodigesters for methane capture, which is something that a number of NGOs are quite excited about, and there are pilots in Kenya as well as in Ethiopia. However, this is really only suitable for zero grazing systems, which we also call intensive dairy. Something that has applicability for more mixed systems would be improving manure storage by using covered heaps. Then the third area, which is very dear to the heart of many of my colleagues here at ILRI, because we do a huge amount of research on animal diseases. So first would just be reducing the chronic disease burden of intestinal parasites. So basically it means that cows aren't digesting a lot of their food because they have parasites in their stomach. So again, it's a huge constraint on their productivity. They don't gain weight. This is applicable in all systems. Of interest just for pastoral systems is the idea of reducing age at slaughter. And then something of interest, but it really only could work in intensive dairy systems, would be looking at artificial insemination to improve breed productivity. Next slide. Okay, so I'm not going to go through all of the details of this, but I just want to illustrate to you that although we couldn't look at it in our study, there are some reports that estimate the technical greenhouse gas mitigation potential of some of these options. For example, improving feed quality could reduce greenhouse gas emissions intensities by up to 25% in the case of lactating cattle in dairy systems in Kenya and Ethiopia. Similarly, if you feed animals high quality silage, you could get almost 48% reductions in intensities in dairy systems. Next slide, please. However, unfortunately, the option that I'm sure is of most interest to this seminar and that will be presented as part of the CBA analysis, it's really hard to get estimates of the technical potential of reducing emissions intensities through managed grazing. And that's because in Kenya and Ethiopia, a lot of that managed grazing is done on dryland systems, and where it's really hard to sequester large amounts of carbon per hectare. And also because we just don't have a lot of reliable information, haven't done much experimental or field data collection on the potential for managed grazing. And then I just want to highlight that manure storage, it is an option that has traditionally only been considered for mixed or smallholder systems, but we've recently done, or colleagues of mine have recently done research on the potential to, so emissions from BOMAs in pastoral systems are actually quite significant, and so we're starting to explore options for manure management in pastoral and agro-pastoral systems. as well. So with that, I want to turn it over to the more significant presentations. I'm really just presenting some background on the work that we did that led into the cost-benefit analysis that Stanley Nganga, who will speak next. Oh, sorry, I forgot my last slide. Thank you very much. I did just want to highlight, although, sorry, can you go to the previous slide? Yes, sorry. I did just want to highlight, though I don't have time to go into detail on this, that a lot of what we spent time on in the report that this comes from was looking at the barriers and incentives. And although Todd will refer to this in the case of climate change adaptation options, I want you to understand that the technical mitigation potential is only the first part. You then have to think about the barriers to adoption. And here on this slide, I'm highlighting those barriers in the case of managed grazing in rangelands. And the investment is really needed in order to put in place the incentives that are highlighted here. So in the case of managed grazing, it's improving market access to drive intensification, and it's coupling the work on managed grazing with recommendations around improved herd management and health. Okay, and now I will turn it over to Stanley Nganga, my colleague from the Alliance for Biodiversity and CIAT.
Thank you very much, Polly. My name is, as Polly mentioned, I'm Stanley Nganga. I'm a development economist for Climate Action and Finance and Investment team in Africa. And I work for Alliance for Biodiversity International and International Center of Tropical Agriculture. Next slide, please. So in this, in the next 15 minutes, I will be taking you through what Polly mentioned about the cost-benefit analysis of improved livestock management practices in Oromia region or lowlands of Ethiopia. And here I would like us to mention that livestock are very, very key in Ethiopia. This is because 17% of the GDP if we look at the 2013 report, it was contributing to around 17% of the total GDP, and this is dominated mostly by cattle. Now, most of in the lowland, Oromia lowland of Ethiopia, the dominant livestock system here, we call it agro-pastoralism. And here, as people may understand, is a kind of a way of life that is based on growing of crops and raising of livestock as a primary means of economic activity. And also this includes, of course, extensive grazing. But of course, we also have the pastoralists who really travel so far and vast with their herd to look for forage that because of seasonality that's associated with the seasons and the availability of rainfall comes. So, and livestock here could really consume a lot of things, and especially the forage that's really available, they consume it nearly 100%, and actually they consume other non-forage material. That's why we are saying that about 120% of forage production is consumed by livestock, and especially so in drought years. And in terms of most of the rangelands, we can say that it's mostly degraded. Next slide, please. So here, this work takes over from what Polly and Todd did, and we looked at three important livestock management practices. And these three, we call them deferred rotational grazing, active restoration of degraded land, and we also have the fodder cultivation. So if you look at the first one, it's like kind of a conservation and the second one is like restoring of whatever is degraded, and the third one is specifically increasing the fodder cultivation. And the three were selected because in this lowland area of Ethiopia, most people, they focus on what you call meat production. So these are really, really important for smallholder farmer to improve. It is very important to improve range quality. It is very important for their livelihood. Next slide, please. So the work that we did at CIAT with CEADIR is on financial and both economic and financial aspect of the analysis, because we are talking of financial because we considered also from what we call farmers' private point of view, and also we considered what we call externalities, for example, carbon sequestration. So for the financial analysis, we focused on what we call financial revenue, especially what is faced by the farms, individual household. So this was done at a household scale, and this is what mostly I will be talking about. And then we have another part of the presentation that we'll be talking about the economic analysis. And in this one, we considered also the social cost and benefit, and this include what we call environmental goods and services. So this included what we call taxes and transfers, because these do not affect GDP. And for this one, we considered it at national scale. Next slide, please. So to give you a little bit of background, so that as we continue talking, you understand what we talk by the three livestock management practice that we are focusing on, I want to delve a little bit deeper in the next three slides, telling you about the three practices. So for the deferred rotational grazing, what we mean here is by resting the land specifically. And resting land, just as it says, suggests, is just removing the animal for 1 or 2 years to allow the regeneration of plants. Now, while the land is recovering, of course, animals must feed, so we have to look for alternative sources. And in this case, most of the people are depending on hay, and also they were depending on other social and physical mechanism of keeping the animals away out of the area that we wanted to be improved or to be restored in that matter. Next slide, please. Active restoration, on the other hand, it means it is really active. It's like you're taking proactive steps. You plant or you reseed with the desired herbaceous kind of species of forage, and you are removing the woody plant, those that may choke the forage, those that may reduce the quality or something like that. So again, you require an alternative area where the animal can be kept during this restoration period. And for that case, this active restoration area that need to be restored, it has to be fenced so as you keep the animals out. So this in the area there, it was done through what we call social institutions, local institutions, and also physical things like really fencing of the area so that animal can be kept away. Next slide, please. So for the fodder cultivation, of course, fodder here we mean crops also that sometimes human can use as a source of food for their own consumption or for sale. And in this case, some farmers were using what we call like wheat, stave, maize, and stuff like that, because they have high nutrition for the livestock. And this they used to supplement their normal grazing. The livestock normally graze sometimes in poor quality pasture, but they supplement it with what we call the fodder. So, and in some cases, some farmers were using what we call like a hedge of forage around their farms where they are planting some crops. So this also was considered as a kind of an improved kind of fodders, and they were using it to supplement their livestock. Next slide, please. So where we are talking about that this study took place is a southern part of Ethiopia. We call it Oromia region. And in this area is a kind of region where we receive around 230 to 896 millimeter, and the rainfall is really, really variable. So it's a semi-arid kind of, and the primary livelihood is a kind of semi-nomadic pastoralism. So here young men usually travel across a large area with their livestock trying to look for pastures. But of course, mostly is the cattle and the camel that go to a very far distances, but sheep and goat usually are very close to their homes. So, and of recent, when we look at the literature, we have seen that in the last 30 years is when the issue associated with cropping started coming up in the Oromia region. Before that, it used seriously to be pastoralism and semi-nomadic pastoralism. So here, the farmer, because of this coming up of farming, people are cultivating like 2 acres or 2 hectares or less. That's the kind of land they have. So majority of them. Next slide, please. So to give you a perspective of where we are talking about, we have provided the map of Africa and where Ethiopia is strategically placed for those who may not be aware, and exactly where we are talking about is the Yabero district. So Yabero is the headquarters of the district we are talking about, and the 3 areas you can see is where we call the pastoral association, where we collect the data from Dadim, Derito, and Harweyu. Next slide, please. So for matter related to data collection, we collected data from pastoral association where the farmers were really aware that these 3 improvement practices had taken place. And in that case, we surveyed 3 farmers from 3 pastoral associations. In one, we collected data on deferred rotation of grazing. In the next, we collected active restoration, and the third one, fodder cropping. And you can see the number of people that we interviewed in each of these. In total, we interviewed 86, and we had a good representation of women. And as you can see, that 2% were women. And the survey asked specifically about these 3 practices. And to be able to understand it very well, we asked the data 5 years before the practice was implemented and 5 years after the practice was implemented, so that we can be able to compare very well the conventional versus the improved practice. Next slide, please. So as I said, we are comparing conventional, what used to be before, business as usual, as compared to improved practice. So in this case then, we were looking at just the incremental value that's associated with the improved practice. So of course, people know that in this area, people use their own labor or household labor. So we valued it also, and we use the going market rate. And the discounting rate that we used after inflation was 12%. But of course, we did sensitivity analysis for also at 7% and 3%. The time horizon that we considered for the different kind of analysis, I told you we did economic and financial. For the financial, we considered the life cycle, the life of the practice, which ranged for 14 to 21. And for the economic analysis, we considered a 50-year period, including issues to do with sensitivity and the impact of drought. You are going to see those results later. So for the economic analysis, we considered also what we call the greenhouse gas emission effect, and we included it in our analysis, and therefore we were able to scale this study up to the national level. Next slide, please. Very good. So here I start to show some result that now we can really see the differences when we consider what we call the financial analysis or financial net present values of the business as usual as compared to the improved practice at 12% discount rate. Now, as you can see in the table here, we have 3 columns. The first one shows the different practices, the improved practices. The second column shows the net present value of business as usual. And the third row shows you the NPV per household, per practice. So for the improved practice, for that matter. So as you can see there are some dollar values there in the table. And the first one shows that the financial NPV was positive for the BAU, for improved practice, except for fodder cultivation, because you can see it has a negative sign. And the possible reason for this negative value is because of what we call the farmer time value of money, of course. And also what the household may attribute to unpaid household labor. So going by the data they provided to us, the NPV was actually, but if we compare the improved practice, you can see the improved practice is a little bit high. You see it's moving to 1740 for the deferred rotation grazing, up to around 3,100 for the active restoration of degraded land. So if we move to the next slide, please. So in this slide, now we see something else. We see that when we look at the incremental financial net present value, that is when we changing from BAU to the improved practice. We can see that again, switching to deferred rotation grazing, it reduced household NPV. You see, because you see it has a negative value of 1,413, and this is largely because of the cost of buying fodder, because as the land is around to recover, because you have to look for an alternative source of the feed for the livestock, because livestock do not understand what you are doing with the land. So when you are doing the improvement, I mean, they continue eating as normal. So this is the cost that's associated. So it causes a deep dive into the farmers' resources. So as you can see, the incremental in financial, when you switch from the active restoration to fodder cultivation, there you can see again, we have a jump from example, for fodder cultivation was negative. Now we have 2,299. Now, and as you can see in the last column, which is a really very important column when it comes to the CBA indicators of profitability of a practice, it shows you that the first practice, the improvement practice, deferred rotational grazing, actually takes a very long period for farmers to do what we call to reach what we call break-even point after investing on this practice, because it takes at least 12 years. When you look at the active restoration, it takes at least 6 years to break even. And when you look at the fodder cultivation, it takes 4 years. So looking at just this table, I can tell you simply, if you are to present this kind of though it has a high implementation cost, but of course you can see as the benefits start rolling in, the payback period is actually very short as compared to deferred rotational grazing for this matter. At this point, I would like now to pass the baton to my colleague, Dr. Gordon, to present the next part of economic analysis. Thank you.
Thank you, Stanley. I'm Gordon Smith with the CEADIR project. I've been working on a wide variety of aspects of mitigating greenhouse gas emissions by changing land use for 25 years. Next slide, please. Okay, Stanley presented the CBA, and all of these activity changes had big upfront investments in making improvements. And even the deferred rotation grazing, which is a passively allowing the land to restore, as Stanley said, had substantial cost in purchasing a fodder during that time when the land was restoring. And so what you find out is a very common result with changing the benefit rate. We did a discount rate. We did a sensitivity analysis where we decreased the discount rate from the 12% baseline discount rate. And as you can see, in all three of the practice changes, the benefit increased. The net benefit, and this is the incremental benefit relative to business as usual, increased as the discount rate decreased. And what this shows is providing more emphasis on the out-year returns from the improved practice, whereas the high discount rate gives more weight to those upfront capital costs. Next slide, please. We also valued greenhouse gas emissions in sinks, and there's two kinds that we looked at. One is the soil carbon, and the deferred rotation and active restoration both improve rangeland quality. We went to the literature and looked at a wide variety of studies, and the most relevant number we could find for a dry land system like this was a modest sequestration which of 1.7 tons CO2 equivalent per hectare, and we assumed that this happened for 20 years and then did not. Fodder cropping was implemented on areas that were previously in grassland, which has a fairly high soil carbon, so we expected no increase in soil carbon under fodder cropping. Polyatrazine presented some results that showed as productivity increases, greenhouse gas emissions per unit of meat or milk produced decrease. However, we found that herd sizes increased. And this analysis is at the financial analysis, as Stanley said, is at the household scale. So as the herd increased, the methane increased. And so we had costs. And let's go into that. Next slide, please. our as one of the commenters noticed, it's very challenging to estimate the social cost of carbon. So we used 3 different rates, but to start here, our baseline rate was $8 per metric ton carbon dioxide. And the key point of this slide is that in the opposite of the financial benefit to the household, where the discount rate decreased, the value to the household went up. This is only the greenhouse gas emissions, so the soil and the methane, soil carbon and methane. As the discount rate decreases, the value either becomes less positive for rotation, deferred rotation grazing, or becomes more negative for the other practices. And that is because in later years, the methane emissions are given more weight as the discount rate decreases. So this is a little bit of a counterintuitive response. Next slide. We also estimated at 2 other social costs of carbon, 15 and 25 tons, US dollars per metric ton carbon dioxide equivalent. It scales linear with carbon price. So if you would like to use a different carbon price, you can take our results and just find the relative ratio of your price to our carbon price and scale linearly. And again, this is for the carbon, the greenhouse gas emission part only. So as the price goes up, the cost of those methane emissions goes up. And next slide, please. And again, that's at the household scale. So we also wanted to scale up. This is the economics analysis. As Stanley mentioned, we did over 50 years. The economic analysis includes these social costs, excludes taxes. And the deferred rotation grazing, which was negative at the 12% discount rate. If you get down to 3% discount rate, it becomes positive. Again, to reiterate, that's because at the high discount rate, the cost of purchasing fodder during the restoration period dominates the net effect to the household, versus at the low discount rate, the out year accrual of benefit from the improved rangeland has more weight in the analysis, and the financial return is positive. For the other two, the financial return became much more positive as the discount rate went down. Next slide, please. This is an area with very frequent mild droughts and periodic very severe droughts. And we wanted to do a model of what is the effect of droughts on the total returns. What you see here is initially the returns, and this is returns, incremental returns by year, are very negative as the household is investing, and then as the improvement becomes productive, the rangeland is improved, you get positive returns, and then there are periodic reinvestments in reapplying the improvements, and then there are periodic major losses from droughts. So the key point here is that the cash flow is highly variable, and there are periods of up to 2 years long with very negative cash flows, which would be very challenging for a poor household. Either they might not be able to afford the capital cost of the improvement, or they might have food insecurity during the time of serious drought. Next slide. So what does this mean when you add up all those numbers over the 50 years? The way to interpret this is the upper row of numbers is our baseline analysis with a mix of normal year and moderate droughts. And the lower row of numbers is what happens when you include serious droughts in the analysis. And so you want to compare that upper number to the number immediately below it. And you can see that the effect of these serious droughts is that it substantially reduces the total cumulative net present value over 50 years. So the droughts matter a lot. Next slide, please. We also scaled up. There's about 14 million hectares of arid and semi-arid grazing lands. We figured that you can't do cropping on the arid lands. You aren't going to get complete adoption of a new practice. Also, please keep in mind that you can do, these are suites of practices, and you can do one suite of practices on any particular hectare, but you can't do both of them. You're not going to do deferred rotation restoration and active restoration on a particular hectare. You do one or the other. So this analysis assumes, what if you can do a quarter of the grazing area in the country and scale up? You've got a per hectare basis if you want to do your own analysis on a per hectare basis, and then scaled up to the country as a whole. And again, that this is the 12% discount rate. You can see that there is substantial benefit, particularly to the active restoration and the fodder cultivation. This, as an economic analysis, includes both the financial returns to the agro-pastoralists as well as those social costs of greenhouse gas emissions. Next slide, please. This slide separates out the value of the methane emissions. As you can see, they're more than an order of magnitude smaller than the numbers you were seeing on the previous slide, but they're still substantial. So the recommendation here would be that if the country wants to pursue this strategy, they might also try to pursue work on feed improvements and other improvements that are going to reduce the emissions per animal. Again, to repeat, just so you get the point, the reason these are negative costs is because the herd size is increased. That's a financial benefit to the farmer if they have more production, but it's a cost because there's more methane. It's a cost to society because there's more methane emission. Next slide, please. And okay, there we go. So, in closing, the active restoration and the fodder cultivation were both incrementally and absolutely beneficial, financially beneficial, and higher than the business as usual. The deferred rotation grazing had a positive return in aggregate, but it was less than the business as usual scenario that we observed in that situation. And all three of these practices have large upfront investments, and that would be a significant policy challenge to figure out how to get that implemented broadly. We found exactly what you would expect. The severe droughts have negative income and bring down the cumulative overall returns substantially. And this was really focused on the dollar values, and it's very important to consider the cultural and social situation and institutional situations that will have a huge effect on whether these practices are adopted, even if they are financially beneficial to the users. And we're very, very fortunate to have brand new work on looking at these social and cultural aspects of adoption of these practices. And so at this point, I'd like to turn it over to my colleague, Todd Crane, to hear about those social and cultural aspects of these changes. Go ahead, Todd.
Thank you very much, Gordon. By way of a quick introduction, I'm a senior scientist in Polly's group at ILRI, working on climate change adaptation and mitigation issues from a perspective of socio-technical change. I'm an anthropologist by training, so that's kind of the framework I begin with. And I'm happy to be in this presentation today because I started my career working on USAID's SANREM, CRISP, and Mali. So it's nice to be speaking back in this space. Next slide, please. So what I'm presenting today is a paper that's just come out in the last few weeks from a USAID-funded project called Local Governance and Adaptation to Climate Change. This was a collaboration between ILRI and our colleagues at the World Agroforestry Center, finished just a couple of years ago. We're focusing on pastoral communities in Kenya and Burkina Faso, trying to look at the governance dimensions that help promote success. And I would note in the title that it says Transitioning Kenyan Pastoralism, because while the place where we work, the Ilingwezi Conservancy, is a Maasai landholding, and Maasai are traditionally pastoralists, when we look at what people are actually doing for their livelihoods, it's a pretty broad mix. So while yes, Maasai pastoralism is kind of the beginning point, and reference point for a lot of people, the livelihood strategies are becoming increasingly diversified, so that label pastoralism doesn't really capture everything that's going on there. And finally, I just emphasize that this is a research project that I supervised, and this is a paper I co-authored with a Kenyan PhD researcher, Teresia Nganga, who will be defending her PhD very soon at University of Nairobi. Next slide, please. So when we talk about climate change adaptation, we're usually framing it in a way that starts with environmental change, that's climate change, and that necessitates a technical change in agricultural practice, land management, whatever it is. But this presentation is outlining how that technical change and that environmental change manifest in socially situated processes, because technologies need to be done by people, by individuals, in households, in communities, and trying to examine how those affect the way that the technologies take hold. So the research objective is to differentiate these different social categories and see how they affect access to and benefits from specific practices. And we're specifically looked at wealth, age, and gender from an adaptation pathways perspective, again, emphasizing processes of change. The three practices that we examine in this paper range from the kind of landscape level community processes to household processes. First was the conversion of the Ilingwezi group ranch into a nature conservancy. This second is rotational or bunch grazing. So how are livestock managed within the pastoral spaces? And finally, fodder cultivation as a kind of a household and a collective, a small-scale collective action enterprise. Now, I hope you might notice that these practices align very closely with the 3 mitigation practices that Gordon and Stanley have analyzed. This project was completely separate from theirs, but we've landed on these coincidentally, and I think that emphasizes the synergy between adaptation and mitigation practices in these spaces, though we're still bringing together the data to substantiate that relationship. Next slide, please. Unlike the previous presentation, this is not a quantitative analysis. We're taking a fundamentally qualitative approach to understanding how adaptation practices emerge from social processes. They don't come from out of nowhere. How they are affected by social institutions and norms, in terms of who gains access to them, who picks up labor burden perhaps, who is marginalized potentially by them, and then that social distribution of benefits. Again, some people are able to reap the benefits while others may not have access to that or the necessary assets to implement. So we're not claiming a representative sample here, but the qualitative analysis and what it's really aiming to do is identify the social mechanisms that lead to social differentiation in these technical change processes, which I will make the case at the end that these have important implications for how programmatic interventions promote their objectives and pursue their objectives. Next slide, please. So the first practice was the conversion of what had previously been a group ranch to a collective tenure on a large piece of land that belonged to the community. After the devastating droughts in the 1980s, the Ilingwezi Group Ranch decided it's harder and harder to make a living off this land as pastoralists, dedicated pastoralists. So let's convert it to a conservancy and try and diversify the economic portfolio of this land through some pastoralism, but some nature ecotourism conservation management. So obviously managing for ecotourism implies a very significant change in land management practices, and the rotational grazing is a part of that. But it necessitated a community diaspora. People needed to move out of the conservancy land holding into villages and residential areas, some within the conservancy, but many indeed outside of the conservancy, but still around the borders. The map here shows every of the red triangle is a village of some sort or another. Some are in and some are out, but all are still members of the community and claim some benefits to the economic flow from ecotourism in there. As a part of this, though, this is a major change in the community organizational structure and the pathways people get and the opportunities they get through this diaspora. And what we found was that there was a small group of relatively wealthy herders in the early days of this who, in fact, divested themselves of large parts of their herds to invest in irrigated land in the Manyangalo village, which is to the lower right-hand corner of the map. And because of this ability to invest in a very new livelihood strategy, they knew nothing previously about irrigated farming or gardening. This is a very new pathway. But what we found over the course of a decade and a half, 2 decades indeed, is that it opens up new pathways in terms of economic opportunities. It opens up, with that, flows of information, social networks that enable them to approach dealing with climatic stress in a very different way than, say, the people who are still herding cattle living inside the conservancy. And in some other villages, people are now getting into farming wheat, keeping small stock in a relatively intensive fashion. So we see a differentiation in economic livelihood strategy that has been substantially influenced by people's asset levels. So again, this is emphasizing that these communities are not homogeneous. And that affects the way that they respond to opportunities and the way they implement and pursue specific adaptation technologies. Next slide, please. As a part of the diaspora out of the group ranch, or now the conservancy, there was part of the land was maintained for dedicated grazing. So we have the part that's managed for nature conservation and tourism. There's a buffer zone, and then there's the dedicated grazing area, and there's reserve grazing. So this is it's a very specific land management strategy. This is developed largely with external information inputs, but it requires moving the livestock around the landscape in a much more deliberate and indeed constrained way. The agreement of this management plan was done by the elders in the community who set policy. However, it's important to note that the actual herding of animals on a day-to-day and week-to-week basis is done by young men, locally known as Morans. And this label is not just to say any old young men, but this is a very important cultural way marker in terms of age set transition, the transition between being a youth to becoming an adult. A very important part of this transitional process is that Morans are meant to spend a lot of time far away from the rest of the community. They're supposed to go out into the bush, have no contact with parents, have no contact with young women, and spend really a couple of years to themselves. However, the practical necessities of rotational grazing in a nature conservancy space makes this very difficult. And so they're more often bumping into elders, they're bumping into young women, they're having contacts that aren't consistent with this experience. And so while the technical promise of rotational grazing is still, I think, pretty strong, it is coming into friction with young men's expectations about what it is to become an adult. And so is actually seeing some resistance in that space. This is not something that had been well anticipated, I think. But again, it emphasizes that these cultural institutions and this set of age set transitions to adulthood become important factors in understanding the success and the feasibility, the social feasibility of these technical practices. Next slide, please. And finally, fodder cultivation, again, is a very popular means of intensification, of reducing the GHG emission intensity in livestock, and as well as adapting to climate change, getting through the dry seasons and the drought seasons more effectively through banking fodder for animals. However, this has the implication of requiring de facto land enclosure in what had previously been a common property pasture. It also requires, or in this community, affects collective action of people getting together to do it not as a single household necessarily, though there are some cases of that, but to do it as a group activity, so that only members of the group have the preferred access to the fodder, or they buy it at a more favorable rate. This has implications in terms of people's asset bases, in terms of their ability to invest and willingness to invest in that. But we analyzed it primarily in terms of gender differentiated impacts. Seeking out fodder for animals left in the homestead while much of the rest of the herd is migrating is women's labor. And what we found is that women were very happy with this fodder cultivation because it meant that they don't have to spend so much of their day wandering in the forest gathering grass, but they simply have it at hand. They can dedicate more time to other things. It also increased women's economic opportunity in terms of women's responsibility of maintaining fences. Fences are a very important part of this, not just to demarcate the space, but to protect crops from wild animals. There are elephants who wander through this pasture on regular basis, among others. So maintaining fences is women's work, and this requires enclosing land with fences. And so this is a fairly rare opportunity to make cash money on a regular basis in what is otherwise a very remote area, difficult place for women to gain cash independently. And finally, of course, in having this fodder at hand in the dry seasons and the drought seasons enables women to feed their milk cows and milk goats in some cases better, thus improving milk productivity, thus them being able to feed milk to their families and their children more regularly and more richly. The value of that, I think, is fairly obvious. Next slide, please. So the take-home points for this, I think, are hopefully are becoming clear, that these social institutions relating to wealth differentiation, relating to age-set perspective on the technology and the practice and on gender, they're really central to the success of any adaptation or mitigation practice. And I would say that's true in any agricultural system, but especially true in pastoral systems. Second is that interventions, if need to consider this social heterogeneity and the way it plays out and the way promoted technologies will play out there in order to meet social inclusion targets. So these are increasingly common in any program to understand the gendered impact and improve women's opportunities. So understanding gender institutions in any cultural context is essential. And finally is that these adaptation or mitigation interventions can't be bracketed apart from other change dynamics. The establishment of the conservancy and its conversion from a group ranch was made possible by land laws. Land laws in Kenya have been evolving a great deal in the last 20 years, for example. So climate change adaptation needs to consider what is land tenure, and then pastoral systems access and tenure is inherently complicated. People's economic aspirations are also a new change dynamic. The expectation of certain consumption patterns affects the way that people want to pursue economic opportunities. Next slide, please. The next slide is passing the mic to Lori.
Thanks very much, Todd. And thank you to all of our panelists for that wealth of material. We'll get to your Q&A in just 1 minute, but I wanted to briefly note a few points here. First, I think Todd's presentation did a really great job of demonstrating that effective interventions need to examine both the economics and the real individual and cultural barriers and opportunities for implementation in specific contexts. And I think a number of the questions in the chat were addressing this as well, like how do these practices sort of come to life in these real settings? So I just want to emphasize that that cultural beliefs and practices and individual household characteristics, even we all know that within communities, households differ from one to another in their beliefs and practices and access to assets and resources. So this really ground level understanding is so important in supporting the best approaches and strategies. So thank you, Todd, for that. And before this next point, I first want to commend Stanley and Gordon on a really impressive cost-benefit analysis that integrates the risks that households face really well. And let me remind you, and I think this came up in the chat as well, that this cost-benefit analysis was just published in September and is available in the links in this presentation and elsewhere. I do also want to suggest that there may be opportunities to broaden cost and benefit analyses to more fully consider some of the co-benefits we've talked about today across the realms of livestock productivity, resilience, and mitigation objectives. And perhaps we'll hear more about that during the Q&A. Next slide, please. So we've reached the Q&A portion of the webinar, but before some people may need to drop off, can we please go to the next slide? I just want to make sure that you all know that we'll be sharing the recording of this webinar, which will include, as shown on this slide, contact information for follow-up. So that will be here in this slide, and also some of that information is available in the invitation you received. Thanks. Previous slide, please. Okay, can I now ask all panelists to turn on their cameras for the Q&A? We received questions from some of you ahead of this event. Thank you very much for those. Some of those questions I think have now been addressed during the presentations, but I want to pose a few of these questions to our panelists now, and also address as many questions as possible from the chat. Let me direct the first question to you, Polly, and I'm actually going to sneak in two questions here. First, can you discuss the major barriers to short-term and long-term progress to reduce emissions from livestock at scale? And I know that's a big question. We don't have a lot of time, but referencing some of those. And the next question hopefully is one more of clarification, but regarding a question in the chat that came up earlier in the webinar, a question about mitigation potential. Can you explain the difference between the life cycle analysis and animal level basis? Thanks, Polly, over to you.
I tried to answer the last question actually in the chat. And so, yeah, mitigation potential estimates can really vary depending on if you do a full life cycle analysis, in which case you would have to include the cost of all the inputs, the feed, the transport of the feed. The estimates I presented didn't do that. They were just from, they just looked at the emissions from the animals themselves, the enteric methane production and the manure management. But yeah, but that can get us into a very, very long discussion. So I don't want to go on with that one. The major barriers to short and long-term progress. I mean, I think there are a lot of social and economic reasons why livestock production, particularly in smallholder systems in East Africa, where the study was based, have not been adopted, and that has to do with why people keep livestock. It's often livestock are often a complement to other production and pastoral systems. The logic of livestock keeping and livestock production is not necessarily about. Although they keep animals for milk yield, the social and the social reasons behind that, the climatic variability that those systems have evolved to manage means that they need to keep larger herds to recover from drought. It also means that some of the improved feeding based options that might work in more intensive or mixed crop livestock systems aren't applicable in more extensive systems where really the bulk of the biomass that livestock consume come from grazing lands. But so what I would say is I don't think enough. So it's not that there are silver bullet solutions to improve productivity. It's more about designing incentive structures to help a range of different producers be more able to adopt the low emissions development practices as we referred to them in the report. And so I didn't have time in my presentation to talk about the barriers and the incentives that we suggest. But one finding that was common across the different production systems is really about market orientation and how market oriented you are. And so in some of our other work, particularly in dairy systems, we found that it's easier sometimes for the more commercialized producers to adopt some of these productivity improving and therefore emissions intensity reducing interventions. But there are a lot of social inclusion dimensions that aren't addressed when you only work through more commercial or formal market systems. So thanks, Lori.
Thank you, Polly. And I'm going to direct this next question to Stanley and Gordon. And I realize now this is a question that came in during registration. It's a bit similar to what I've just posed to Polly, so it might be an opportunity for you to build on it a little bit. But more specific to the practices that you introduced during the CBA, what are the opportunities to actualize and advance the potential for improved cost benefit and the promising livestock management practices, both with pastoralists and agro-pastoralists? And in particular, is there a role for financial instruments, markets, which Polly started to mention or mentioned, government, and compensation for environmental stewardship, either by government or development partners? And then the follow-up, of course, to what are the opportunities is what are some of the barriers? And I'm certainly not asking you to repeat anything that Polly just addressed, but if there's things to build on from that would be great. Thanks.
Okay, so this is Stanley. So if I go fast, I will thank you very much for the question about the opportunities to actualize and advance the potential benefits of these improved practices. So the first thing to say is that when you consider these practices, especially when you consider all the data that we collected, what comes out very important is the need to consider the lag, the time lag, which means where the time that it takes before the positive impact starts to be realized on the productivity, or the productivity to start being realized. And as you saw in the numbers, for example, in the deferred rotation of grazing, you could see, for example, it takes 12 years for the break-even to start being realized. Now that shows something very critical if we want to think about the opportunities and the potential of improving, especially the farmers, the pastoralists and agro-pastoralists. Because what we have to think about first is what do farmers care about most? The first thing that farmers care about most, farmers do not think about GHG emission on the ground. That is a very secondary thing for them to think about. They don't think about land degradation, which is again some losses that may cause a lot of negative impact in their livelihood in the future. But at the moment, they may not think about that. What they think about most is what goes into their pocket, like to improve their livelihood. So when we think about the potential impact for improving the life of the pastoralists and agro-pastoralists, then we have to think about how are we going to help the farmer manage their livelihood, like in the present time, so that they can be able to consume some of the benefit that may come or be realized later on. For example, reduce GHG emission, reduce soil degradation. Because some of this, they cause what we call degraded rangeland, and that combined with the impact of the climate change, which is very erratic, for example, erratic rainfall, frequent drought, it really impacts on their livelihood. So before we can think about the productivity, so that we have a very good entry point for the opportunities of the livestock management, we have to think, for example, on what USAID did some time back in Ethiopia. And I say this because sometime back, I heard of this project that USAID did with the government of Ethiopia to recognize the customary and pastoral land uses, and they help in supporting, for example, the demarcation and certification. So the USAID help the government to relieve some of the immediate issues so that the farmers can be, the government can help to formalize the customary institutions, because these are key. I mean, you strengthen them, you strengthen the rules and the norms on the ground, and then you can be able to allocate the authority of the land use right for crop production. So until we think in that way, then the opportunities may never be realized, you see, because a payback, for example, of 2 years or more is really large for smallholder farmers who are depending on this livestock for day-to-day livelihood. Also, when you think about issues like the impact of drought, I mean, it brings a lot of negative issues. So if we think about the opportunity, of course, there are a lot of opportunities, but we have to think about the strategies that we have to put in place for the ground as an alternative sources of as just an example, as when they were taking their livestock away, the livestock had to feed. In this case, also, we have to think about the livelihood of the farmers now, so that we can be able to put into place mechanisms that can help the future benefits for the larger number of households to be realized later on. I passed it to my friend Gordon to say something about this also.
That was wonderful. Thank you, Stanley. I'll just add a couple points. Yeah, I think if this is going to be widely adopted, there would have to be a large program to help provide that investment capital. Most of these smallholder farmers are very poor and they don't have the assets to make the investments in these practices if they're positive. Another piece is that traditionally cattle have been a store of wealth. I think it'll be very interesting to see that as financial services become available to people, and the big example here is M-Pesa in Kenya. If you can bank on your phone, will people start storing wealth in money? And in particular, if they get information that a drought is starting, will they sell animals while the animals are still healthy and still high value and store the wealth through the drought as money and then go back to cattle or livestock after the drought? I think that'll be very interesting to see if people start doing that more. Another very important social implication that Stanley alluded to and went over quite quickly is that, this is in the context of increasing population, and there's more and increasing claims on land, and there is less and less ability for pastoralists to move livestock to the areas where they have moved them in past decades. And these improvements with rotational grazing and managing livestock and fodder cropping have an effect of, even if not legally privatizing land, functionally privatizing land. And as Stanley mentioned, to make investments, that's easier if there's even legal privatization of land. And so that's a fundamental shift in society, and we need to recognize that. I'll stop there and we can go to another question.
That's great. Thank you, Gordon, and thank you, Stanley. I think you raised some really important points there. Todd, I'm going to direct the next question to you. You note in your presentation that interventions cannot be bracketed apart from other change dynamics that people are facing. Can you say a bit more about other significant change dynamics that you are seeing in your study areas and how these interact with climate change interventions at a household level?
Okay, yeah, and I think Gordon and Stanley have already started to move into this territory very usefully, is that changes in land tenure laws are significant. Changes in especially in pastoral systems, changes in mobility capacity, in the way mobility is regulated, or in many cases disabled through land enclosure and the cropping over of what had been pathways. That's not a climate change issue directly, but it shapes fundamentally the environment in which people pursue options. Expectations of gender equity, largely but not entirely promoted by international organizations, are an aspect of that. Yeah, those are the two big ones. In Kenya, especially, devolution has become a very major shift. That's more power is now placed in counties, which have only existed for some years now, and the process of distribution of power and mandates between national government and county governments is still being worked out. So the kind of the pathways of governance and accountability, into whom do you appeal to pursue an option, to get information, to get access to technology. I would note in this case that in Ilingwezi, the implementation of fodder cultivation was substantially supported by county extension, because pastoralists don't know anything about growing grass. Grass is the gift of God's bounty. It's out there, you go get it. So this having extension staff that you can appeal to help that technical change is an important part of it.
Great. Thanks, Todd. This is a question that I think all of our panelists could answer. Todd, I might let you start with it. Gordon had also started to address this question a bit. The question is, selling live animals is not promoted by pastoralist communities unless there are potential shocks, such as drought. And of course, larger flock size is often a measurement of status. How can we tackle such challenges as we consider these livestock management options that we've discussed today? So again, Todd, I might point that to you, but I think others may want to follow up on that as well.
Yeah, the status driver is very real and still very present. It is shifting. Again, I wasn't able to touch on it in the presentation, but there are kind of the intensive fattening, animal fattening and selling operations are found in Ilingwezi, in that area. But again, they tend to be something that an older generation actually finds more alluring, partly because it means you're not wandering around the landscape all the time, partly because they've maybe more accepted the writing on the wall of livelihood change, whereas some youths are still trying to pursue their cultural patrimony, if you will. I would start, and this risks being a predictable answer from an anthropologist, but start by accepting that those are real reasons people keep livestock and accepting them. That's legitimate. And people do respond to new opportunities and economic opportunities as they come. But I think we need to be careful not to try too hard to shoehorn people into our models, our notions of what's going to work, but to present people with opportunities, and some will pick up on them and some will not. Though I would emphasize that in interventions along this line, we need to pay close attention to those who either will not or cannot invest in these opportunities, and what are the implications for them? Because we tend to look at the adopters as the indicators of success, but how do we look at non-adopters as an outcome?
Great, thanks. Does anybody else want to add to that? I might just let you jump in if you would like to.
I would like to jump in a little bit and say the following. I think what Todd mentioned is very, very key, that we present them the options. Of course, you provide them with the options and opportunities in each of the options, what we call the advantages and the disadvantages. But of course, you allow them to make the decision. But then we have another role to play. How do we help them to make the right decisions? My friend Gordon said something that was very important, that when you go to the pastoral areas, even though you may provide them what we call the information about an upcoming drought, they have a serious attachment with the livestock. They may not just let the livestock go, even if they see forthcoming serious signs of drought. So then something needs to be done. I think one of the things would be an enlightenment, a program that could help the pastoralist to have a serious understanding of the way maybe letting their livestock go and keeping it in value in dollar terms and then getting it back would help. So this would mean a serious enlightenment, because then you have to touch into some of the issues that Todd is mentioning, technical, social issues, and some of them are cultural beliefs. So this is a very, I don't know how to go about that one, but I think something to to do with the enlightenment through education programs and then social programs to support them. For example, when they sell their animal, they can be assured that they can get their money back. Some of these households, when you go to the rural areas, are really large households. So when they get the money from livestock, they may never buy the livestock back, even when the situation improves, because whoever is making the decision is a household head, and in between when the drought is taking place, he may see other interests, and in that case, they may not get back the hard size they were into before. So these are some of the issues that even when they are making the decision, they think, okay, if I let it go, I may never find it back. They don't look at it in terms of the value. So a serious enlightenment, talking about cultural issues, and other technical issues, such as those that were covered by Todd in the study, I think we need to look at what we call a really pragmatic approach that looks at all the dimensions and is really inclusive. And also to hear the perspective of these pastoralists, why they do not do some of these things, even the strategy when it's provided. Because sometimes we think what we provide is the best, but of course we need to also to hear their voice. So it's like a to and fro. We run, they run. We run until we come to a ground where things can start to shift. Thank you.
Thank you so much, Stanley. And Gordon, I know you wanted to jump in there. And of course, I'm looking at some of the questions coming in on the chat, and there's so much more I would love if we could address, including these questions about anticipating risk in our cost-benefit analyses, and drought frequency is something that I think is really important. But unfortunately, we are at our time. So we do need to wrap up. There's certainly some questions that we have not had a chance to get to. And I encourage you to have a look at the publications that are here on the next slide in the references. And you also have contact information for the panelists, and you're welcome to be in touch. I want to thank all of our participants for joining us, and give a special thanks to our colleagues from ILRI and CIAT for presenting their work. And thank you to the SEEK project for hosting our webinar today. Thank you very much, and please stay tuned for CEADIR's 4 remaining webinars. Thanks to all of our panelists, and thank you to our participants. That's it for today. Goodbye.